So, welcome to today's lesson on classifying triangles. We are going to be working on a bunch of different concepts here today. We are talking about different types of triangles. First of all, we're going to talk about angles in triangles. So, we have several different kinds of ways to classify triangles just using their angles. This triangle is equiangular. That means that all the angles are congruent. You'll notice that that's right here, right here, right here. Those are all congruent. The next one is an acute triangle. All the angles are acute. So that means they are all less than 90 degrees. Less than 90 degrees. So this angle is less than 90, this angle is less than 90, and this angle is less than 90. The next one is a right triangle. We've been dealing with right angles. Now we've been looking at right triangles. A right triangle has one right angle. Right there. Finally, we're looking at the obtuse triangles. Obtuse triangles have one obtuse angle. This one right here is obtuse. All right, moving on. We can classify triangles by their angles, and we can classify them by their sides. Remember last page we had equiangular, now we have equilateral. Lateral means sides, so the sides are all congruent. So in this case, this side is congruent to this side, which is congruent to this side. We have a scalene triangle. That means no sides are congruent. This side is one length, this is a second length, and this is a third length. Finally, we have an isosceles triangle. Isosceles means that two of the sides are congruent and the third one is not. We also are going to be talking about exterior angles as well. The exterior angle of a polygon is, if we extend this aside, it's the angle that's right here. That's an exterior angle. We also note that we have remote interior angles. Remote interior angles mean the angles that are opposite this angle. So these are remote interior angles. They're inside the triangle, and they're opposite this other angle right here. Okay. So the triangle sum theorem, we've been doing a little bit of this already. Just means that the angles inside of a triangle add to 180. The triangle exterior angle theorem says that this angle is the same measure as the sum of these two angles. So now we're going to draw a triangle to fit each description. And then we're going to mark the triangle to show what we know about it. So for an obtuse isosceles triangle, obtuse is the angle, isosceles is the sides. So we have an obtuse, which means that it's larger than 90, obtuse. An isosceles means that these sides are congruent. So you mark it just like that. Now we're going to do a scalene acute angle. Okay, so scalene means that all the sides are different, and acute means that all the angles are less than 90. So we go like that, and like that. All of those sides are different. And all of the angles are less than 90. Now we're going to do an acute equilateral. Acute means that all the angles are less than 90, and equilateral means that all the sides are the same. All the sides are the same, and all of the angles are less than 90. Okay, so now we're going to move on and use some algebra with it. So I see that we are supposed to look for this isosceles triangle and find the measures of the sides. Well, that looks crazy hard, but it's really not. Because if we use that vocabulary word isosceles, we know that two of the sides are the same. And in an isosceles triangle, the base, KL, is the one that's not the same. So I'm going to tell you that this and this are congruent. Well, if those two sides are congruent, we can set them equal. So we've got 4D minus 13 equals 12 minus D. So now all we have to do is add D, 5D minus 13 equals 12. Now we're going to add 13 to both sides. We get 5D equals 25. Divide by 5. And D equals 5. Well, we're not quite finished with that, though. So now it says, find the measures of the sides. Up here, find the measures of the sides. So that means we have to take this D and plug it back in. So I'm going to plug it into this equation right here. And I'll do that in a different color. I'm going to plug D into that right there. So 12 minus D, which happens to be 5, equals 7. So I know that this side right here is 7. Well, the beauty of it is I don't have to plug it into this side over here because those are the same. So I'm going to say this side is 7. And if I look at the base now, I'm going to plug the 5 into that. 5 plus 6 equals 11. So that's this side right here. So you have all of those sides. All right, now the next one. I'm going to highlight some of the vocabulary that we have here. We want to find x if we have an equilateral triangle. And it's telling us that we have one side, AB is 6x minus 8. BC is 7 plus x. And AC is 13 minus x. So if I draw this triangle, and it doesn't matter what it looks like, it just helps you to see it. All right, so I'm going to put AB right here, which is 6x minus 8. BC is 7 plus x. And AC is 13 minus x. So if it's equilateral, that means I can choose any two sides and make them equal. So I'm going to take 13 minus x and set it equal to, I don't know, let's do 7 plus x. So first I'm going to add x. So I end up with 13 equals 7 7 plus 2x. I'm going to take 7 away, that gets 6. And then we have 2x divided. So x is going to be 3. And now it says find the measure of each side. So I'm going to plug it back in to one of these expressions here. And why not do 7 plus x, because that's really easy. So 7 plus 3 equals 10. So each side is going to be 10. Now, if you've gotten this far with me, you have been listening very well, and I know that most of your classmates are not listening to the tapes. So what we're going to do is we're going to do something a little fun here, and I'm going to ask you all who are listening to the video to actually make a little smiley face next to your name on the front of your note sheet. If you have that smiley face there on the front of your note sheet, I will know that you listened to this message, and we will be doing something a little bit extra for you guys. If you know that there are people who are not listening to the video, don't tell them. Let them figure this out for themselves. So remember, just make a little smiley face. All right, so we're going to move on. Number 4, find the values of the variables and then the measures of the angles. Okay, so now we're using the triangle postulate that says that all the angles inside of a triangle equal 180. So I'm looking at 70 here, 30 here, and x. Well, 70 plus 30 plus x is going to equal 180. We just know that now. So this is 100 plus x equals 180 minus 100, x equals 80. So now we can say this is 80 up here. And we know also that y is going to be congruent to 80 because y is a vertical angle to x. So y also equals 80 degrees. Next one. Okay. This is not so crazy as you think. I see a little bit of algebra here and here, but I know that because the box is here, this is 90. So when we add all 3 angles up together, we're going to set it equal to 180. So 8x minus 1 plus 4x plus 7 plus 90 equals 180. All right, so the first thing we have to do is combine like terms, 12x, and we have that right there, 97 minus 1 is 96, so plus 96 equals 180. 12x equals 180 minus 96, which is 84. Divide by 12, divide by 12, x equals 7. So we have the 7, but we still haven't finished yet because we have to plug it right back in. So I'm going to plug it into this one right here. It just looks easier. It doesn't matter what I plug it into. So this is going to be 4 times x plus 7. So that's 28 and 35. So this angle right here is 35. We don't have to necessarily plug it in here. We can say 90 plus 35 plus y equals 180. So I end up with 55 right up here. All right, moving on. Now we have to figure out what x is on this one. Well, remember the remote interior angles add up to the exterior angle. So the remote interior angles are the same as x. So we add these guys up, 50 plus 70, and that's going to equal 120. So x equals 120. Finally, now we have algebra instead of nice numbers. So it's the same concept though. We're going to add the remote interior angles to get 6x. So that's going to be 3x plus 10 plus x plus 40 equals 6x. So we're going to combine like terms. 4x plus 50 equals 6x. I'm going to take 4x away. Oops, not 40x. 4x minus 4x. 50 equals 2x. So divide by 2, divide by 2, and we have 25 equals x. And then we can plug it back in and figure out what they are. 25 down here plus 40 is going to be 65. 3x is 75 plus 10 is 85. And then 6x, 6 times 25 is 150. All right. Here we go. Have a great night. We'll see you tomorrow.